In this one, we're evaluating the limit as xy approaches 0, 0 of x to the fourth minus y to the fourth over x squared plus y squared. Okay, direct substitution. I didn't mention this in the last one, but maybe I should mention it. Direct substitution you can't do here. You get 0 over 0, which is indeterminate, right? But you always check it in the back of your mind or in the front of your mind at first, right? 0, 0, 0 over 0 doesn't work. But it doesn't mean the limit doesn't exist, right? So how about the difference of two squares up top and using that old trick of getting stuff to cancel? So now one thing I'm going to insist on is you use correct notation or you'll lose a point or two, depending on how bad the notation is that you use. So don't lose the limit symbol along the way. So you get the limit. No, I feel sorry for people who have bad handwriting because I'm one of them. Now there was the paraboloid on the test. I did on a couple of papers, although they kind of had the right idea, the picture was so bad that I took off just 1 point for aesthetics. Just 1 out of 12. That's not bad, right?
But on the first day you said you don't have to be a good artist because I'm not. Are you lying to us now?
But I showed you so many times how to draw a paraboloid. And it didn't affect most people, but if it's just 1 point, don't be mad at me. Just remember, a paraboloid. No, look. There it is. It's not hard, right?
What did they draw?
Oh, I couldn't even reproduce it if I tried. Okay. All right. So factor x to the fourth minus y to the fourth is using the difference of two squares factoring formula. What do you get? X squared plus y squared times x squared minus y squared. That's on top, right? And then x squared plus y squared on the bottom. So you get this nice cancellation, and the offensive denominator goes away, right? That thing causing 0 in the denominator goes away upon direct substitution. And I think it's okay once you get to this point, to check to see if direct substitution works now, and it does. You get 0 squared minus 0 squared. You get 0. It would be a removable discontinuity. So the idea is this function equals x squared minus y squared everywhere except where the denominator equals 0, right? X squared plus y squared equals 0. And in this case, that's where both x and y equal 0, right? Yeah. But we're not allowing x and y to both get to 0, so it's perfectly reasonable to say that the limit of the fraction x to the fourth minus y to the fourth over x squared plus y squared is equal to the limit of x squared minus y squared, because we're not actually getting to 0, 0. But yeah, this guy is undefined as 0, 0, definitely. Everywhere except at 0, 0, this guy is equal to this guy. And by the way we define limits then, they should have the same limits at 0, 0, because we never actually get to 0, 0.